Disclaimer: this podcast is for educational purposes only. It is not medical advice. Always consult a qualified healthcare provider before beginning any new supplement, peptide, or therapy. Today we are going to dive deep into Orexin B peptides. If you have ever wondered how your brain regulates wakefulness, energy, appetite, and even motivation, this episode will be fascinating for you. Orexin peptides, sometimes also called hypocretins, come in two main forms, Orexin A and Orexin B. They are neuropeptides produced in the hypothalamus. They act as signaling molecules that influence a wide range of physiological processes. Orexin B specifically has a slightly different structure and receptor binding profile than Orexin A, and its role is often tied closely to maintaining wakefulness and arousal states. Imagine your brain as a complex orchestra. Orexin peptides act as conductors that keep the tempo steady. Without them, the music becomes sluggish, sometimes grinding to a halt. That is essentially what happens in conditions like narcolepsy, where orexin signaling is deficient. Orexin B helps stabilize wakefulness by binding mainly to the OX2 receptor, while Orexin A can bind both OX1 and OX2 receptors. This difference gives Orexin B a unique role. Research shows that Orexin B has strong effects on promoting wakefulness. In animal models, infusions of Orexin B increase the amount of time spent awake and decrease rapid eye movement sleep. Some studies suggest that Orexin B might have less impact on feeding behavior compared to Orexin A, but its role in maintaining alertness is critical. The fascinating part is how targeted Orexin B's actions can be. Think of it like a specialized tool, rather than a general stimulant. There is also interest in Orexin B for mood regulation. Some evidence links orexin signaling to resilience against stress and even the regulation of reward pathways. This means Orexin B might not only keep you awake, but also influence how motivated or emotionally balanced you feel. For example, experiments have shown changes in Orexin B signaling in relation to depression, addiction, and anxiety models. It appears that Orexin B plays a supportive role in stabilizing the emotional landscape. Another interesting aspect is the connection between Orexin B and energy metabolism. The hypothalamus is the central hub for energy balance, and orexin peptides influence how the body uses glucose and fat. Orexin B can enhance sympathetic nervous system activity, which ties into increased energy expenditure. That means Orexin B could indirectly help regulate weight and metabolic health, though its effects are subtler than peptides designed specifically for fat loss or appetite control. Let us pause and think about sleep. Most people take sleep for granted until it becomes disrupted. Orexin B, along with Orexin A, is a key player in preventing unwanted transitions into sleep during the day. In narcolepsy, the loss of orexin-producing neurons leads to sudden and uncontrollable sleep attacks. Treatments aimed at modulating orexin receptors are being studied, with orexin receptor agonists as a promising future therapy for disorders of excessive sleepiness. Orexin B's strong binding to the OX2 receptor makes it a prime candidate for this research. From a therapeutic standpoint, the interest in Orexin B is expanding. Some pharmaceutical research is investigating synthetic agonists that mimic Orexin B to treat narcolepsy and possibly depression. Others are looking at orexin receptor antagonists, which have the opposite effect, for use in insomnia. That means orexin signaling can be targeted from both sides, depending on whether someone needs more wakefulness or better sleep. It is also fascinating to explore the relationship between Orexin B and addiction pathways. Dopamine, the neurotransmitter tied to reward and pleasure, is influenced by orexin signaling. Orexin B can affect dopamine release, which may contribute to the drive for rewarding behaviors. This connection has led to studies on whether manipulating Orexin B could help treat substance use disorders or compulsive behaviors. When we look at orexin peptides more broadly, Orexin A often gets more attention. But Orexin B should not be overlooked. Its selectivity and strong OX2 receptor activity make it uniquely powerful in the regulation of arousal and wakefulness. Some scientists argue that Orexin B may be the more essential of the two when it comes to stabilizing sleep-wake cycles. What does this mean practically? For most people, it highlights just how delicate the balance of brain chemistry is when it comes to energy and alertness. It also shows how future therapies might harness Orexin B or orexin-like compounds to improve lives. Whether that is through helping people with narcolepsy stay awake, supporting mental health, or fine-tuning metabolism, Orexin B has exciting potential. Let us think about how Orexin B interacts with stress. During times of high stress, orexin activity often increases, which makes sense because your body needs to stay alert. But chronic stress can alter this system, sometimes leading to fatigue or disrupted sleep. Understanding Orexin B's role here could open doors to new stress management therapies. Animal studies also suggest that Orexin B has cardiovascular effects. By stimulating sympathetic activity, Orexin B can increase blood pressure and heart rate. This is a reminder that while Orexin B can promote alertness, it must be carefully balanced because overstimulation of this system could contribute to cardiovascular strain. This is part of why orexin-based therapies are still under careful investigation. Another point of interest is how Orexin B interacts with other peptides and neurotransmitters. For example, orexin signaling can influence histamine neurons in the brain, which are also important for wakefulness. It can also interact with dopamine, serotonin, and norepinephrine systems, weaving Orexin B into a complex web of brain communication. This interconnectedness is what makes Orexin B so powerful, but also so tricky to isolate in research. For those fascinated by cognitive performance, Orexin B raises interesting questions. Could enhancing Orexin B signaling improve focus, memory, or productivity? There is no definitive answer yet, but early findings suggest orexin activity supports sustained attention and vigilance. Imagine a therapy that safely boosts Orexin B activity in people struggling with chronic fatigue or attention deficits. That possibility is part of what excites scientists about this peptide. Let us also remember the evolutionary perspective. Orexin peptides are conserved across many species, underscoring their importance. They likely evolved to help animals stay awake and alert when searching for food or avoiding predators. Orexin B's selective action may have provided a survival advantage by keeping organisms responsive to threats while conserving energy. As we move forward, clinical trials will continue to shed light on how Orexin B therapies could be used. There are still challenges. Delivering peptides into the brain is difficult because of the blood-brain barrier. Synthetic analogs, or small molecules that can cross into the brain more easily, are being explored. These advances could unlock the therapeutic potential of Orexin B in real-world treatments. The story of Orexin B is really the story of balance. Too little orexin activity, and the brain slips uncontrollably into sleep. Too much, and there could be overstimulation, anxiety, or cardiovascular stress. The future of Orexin B research lies in finding the sweet spot where benefits can be harnessed without tipping into side effects. Disclaimer: this podcast is for educational purposes only and does not replace professional medical guidance. Always talk with your healthcare provider before considering any new supplement, peptide, or treatment. Thanks for listening. Keep learning and stay curious.